Welcome to The Explainer. We're jumping right in today because we've got a truly epic quest on our hands. We're digging into a fascinating, definitely dense mathematical paper by H. L. Hussein titled A Gröbner-Shirshov Basis for Nilpotent Rhoda-Baxter Algebras of Weight Zero. I know, that title is a total mouthful, but once you get into it, it actually unfolds like this incredible, heroic narrative. It's really the story of how mathematicians managed to forge an invisible constitution to tame abstract algebraic chaos and ultimately bring order to an infinite void. So let's set the stakes here. Think about this for a second. What actually happens when the rigid, unbending laws of mathematics threaten to collapse into infinite chaos? We rely on math to be exact, right? To give us that one true answer. But what if the equations themselves just lose their fundamental order? What if a system gets so sprawling and massive that we literally can no longer tell if two statements are actually saying the exact same thing? That is the terrifying and honestly totally thrilling starting point for our journey today.
Section 1. The Algebraic Wild West.
Okay, so we begin in what mathematicians call a free associative algebra. The absolutely key word there is free. Picture this sprawling, infinite mathematical landscape where letters and variables can just multiply endlessly. There are no strict boundaries whatsoever, no limits telling them when to stop or how to behave. You could have x times y times z just stringing along into infinity. It's this chaotic realm where variables run totally wild, creating a mathematical system that's dangerously fragile simply because it completely lacks overarching structural rules. Section 2. The Rhoda-Baxter operator. Well, we obviously need some kind of force to step into this Wild West and start laying down some architectural laws. Enter the Rhoda-Baxter operator. We're just going to call it R for short. Originating from Baxter's work back in the 1960s and heavily utilized in super advanced physics like quantum field theory, R is this immensely powerful linear operator. Think of it as a structural dictator of reality. When R is applied to our chaotic variables, it forces them to obey a specific complex identity. It basically steps right into the infinite void and starts manipulating and structuring the algebra, forcing it to fall in line. But here's the catch. Our protagonist has a fatal constraint. And this is what brilliantly illustrates the tension in our entire system: nilpotency. Specifically, Hussein's paper focuses on a nilpotent operator, where r to the power of n equals exactly 0. What does that mean? It means if you apply this powerful R operator over and over again, nesting it inside itself like a Russian doll, eventually it hits a hard limit. Once you hit that specific number of applications, n, its power completely zeroes out. So it's this incredibly powerful force, but one that's inherently destined to collapse into nothingness if you push it too far. Section 3. The word problem threat. Right, so we have our chaotic universe, and we have our constrained protagonist. Now we face the existential threat that really kicks off our central conflict. In math, this is known as the word problem. In our free associative algebra, because variables can be manipulated in so many crazy ways by our R operator, we run into a genuinely terrifying scenario. You might be staring at two massive, incredibly complex equations and have a fundamental inability to determine if they are actually the exact same entity, just wearing different mathematical disguises. If we can't measure truth, if we can't definitively identify identical equations, the entire algebraic system risks a catastrophic collapse. It basically means our math is broken. So the absolutely crucial point is how this word problem actually manifests. It happens through what are called overlap ambiguities, or critical pairs. Imagine a single complex equation. The rules of our universe might allow us to evaluate it by going down path A. Maybe we apply our nilpotency rule and collapse a nested term straight down to 0. But wait, actually scratch that. The rules also allow us to go down path B, applying the Rhoda-Baxter relation to split the equation into even more complex nested operators. It's literally a clash in reality, an equation trying to split into two completely different directions. If path A and path B don't eventually evaluate to the exact same thing, we have a paradox on our hands. Section 4. Forging the basis. To prevent this paradox, we desperately need a solution. And Hussein forges an unbreakable anchor of truth for the absolute simplest case, where our nilpotency limit, that fatal constraint n, is just 2. Look at how beautifully simple the universe becomes here. It requires only two basic rules to force a topological collapse and restore peace. Rule 1 takes two side-by-side operators and forces them into a nested structure. Rule 2 is our nilpotency. If an operator is nested twice, it instantly collapses to 0. By strictly enforcing just these two rules, all those terrifying overlap ambiguities miraculously resolve themselves. The chaos is tamed. But we've got to move forward and see how this builds, because the paper definitely doesn't stop at n equals 2. What happens when the nilpotency limit reaches 3 or 4 or, 100? The complexity absolutely explodes. The moment n is 3 or higher, Al-Hussein proves that those two simple rules, they aren't nearly enough anymore. Suddenly, the system requires 6 massive, intricate families of relations just to keep the chaos in check. Section 5. Resolving mathematical chaos. So we dive right into the literal algorithmic battle of resolving those 6 massive families of relations, which the paper labels R1 through R6. To actually prove that R1 through R6 form a true Gröbner-Shirshov basis, Al-Hussein has to walk us through a rigorous step-by-step algorithmic filtering process. Step 1. Identify absolutely all critical pairs, every single instance where path A and path B threaten to diverge. Step 2. Systematically apply these newly discovered R1 through R6 basis relations to break down the complex nested operators. And step 3. Prove that no matter which path you take, they both eventually reduce to absolute triviality, meaning the difference between them is exactly 0. It's an intense, grinding mathematical filtering process that completely strips away the microscopic noise. Al-Hussein actually summarizes this monumental task perfectly in the paper. The basis is found by, quote, systematically resolving all overlap ambiguities between the basic relations derived through careful critical pair analysis. It's one thing to read that sentence out loud, but when you look at the actual proofs in the paper, wow. It involves pages upon pages of untangling deeply nested Rotobacter operators, meticulously tracking exponent patterns just to make absolutely sure the architecture holds up and no paradox can survive. Section 6. The ultimate harmony. Once Al-Hussein proves that R1 through R6 resolve every single ambiguity, this profound mathematical law kicks in, the composition diamond lemma for operated algebras. You can basically think of this lemma as the ultimate cosmic treaty. It guarantees, mathematically, that because all our overlapping rules have been proven to resolve, our invisible constitution holds strong. It ensures that any equation, no matter how chaotic or hopelessly complex it seems at first glance, will inevitably be filtered down to a single, unbending, and unique truth. And this treaty produces what is called an irreducible basis, giving us our normal forms. This is the perfectly clean final state of our universe. The rules are absolute. First, no side-by-side RU-RV factors are allowed to exist at all. They are entirely processed out. Second, every single R factor is strictly capped at a power of n-1, right before it would zero out anyway. And third, all those dangerously complex nested R-squared patterns we talked about, entirely filtered out. By defining this irreducible basis, Al-Hussein has officially solved the word problem for these specific algebras. The chaos has been completely, perfectly transformed into harmony. So what's the big takeaway here? We've just traced how human minds can reach into an abstract, infinite, and inherently chaotic mathematical space and somehow discover an underlying unbreakable structure that forces it all to make sense. It's honestly breathtaking, which leaves us with a deeply provocative thought. If our chaotic, infinite universe, whether we're talking about the physics of quantum fields or abstract algebra on a chalkboard, perfectly obeys this uncompromising, invisible mathematical constitution, who or what wrote the rulebook? Thank you so much for joining me on this explainer. I really hope this sparked your curiosity, and I'll see you in the next one.